Hey everyone, so let's talk about Mojo. The latest updates are out, and we're not just talking about minor tweaks here. This is a massive leap forward, turning Mojo from a really promising language into a true production-ready powerhouse. We're about to dive into some seriously cool stuff, like code that writes itself, and the kind of total resource control that you usually only see in languages like Rust or C++.
So here's the game plan. First, we'll look at the big picture, where Mojo is headed. Then we'll get into the magic of how you can write less code that does more. After that, we're exploring total control over your resources, some major speed boosts, and finally, what all of this really means for you as a developer. All right, let's kick things off. You know, these latest updates really feel like a turning point. We're seeing Mojo mature, adding these incredibly robust, low-level features that push it way beyond the experimental stage. This is Mojo getting serious about production-grade systems programming. And this is what's so fascinating. Mojo is stretching its wings. It started with a strong focus on AI, right? But now it's clear the ambition is so much bigger. With this new level of control, it's stepping into the ring with heavyweights like C++ and Rust, offering the best of both worlds. So how exactly is Mojo striking that balance between raw power and developer productivity? Well, a huge piece of that puzzle is something called metaprogramming. And specifically, we're talking about a feature called reflection that, well, it pretty much lets your code write itself. Okay, so what in the world is reflection? The best way to think about it is this. You're giving the compiler the actual architectural blueprints for your data structures. And with those blueprints, the compiler can just automatically build all the tedious code for you. Think serialization, comparison functions, all done without you writing a single line of it. And I mean, we are getting deep here. The compiler can now see everything at compile time, field names, data types, even their exact byte offsets in memory. It can even check if your types follow certain rules or traits. This just opens up a universe of possibilities for automated coding. And this is where it becomes a real game changer in your day-to-day. Instead of manually writing out hashing inequality functions for every single one of your structures, Mojo just looks at it and says, hey, all the fields inside are already hashable, so I'll just handle it. And just like that, all that boilerplate code, gone. Poof! All right, this next one, this is for all you systems programmers out there. We are talking about a new level of absolute total control over memory and other resources. This is for when you need to know with 100% certainty how things like files or network connections are being managed. This is done with something called linear types. Think of it like a special library book. You can't just walk out with it. You have to manually check it out, and you absolutely have to return it before you leave. The compiler is the librarian, and it will not let you compile your code if you forget to return that book or, close that file. It's a guarantee against resource leaks. And this slide just lays it out perfectly. In most languages, cleanup is implicit, which is convenient but can hide some really nasty bugs. With Mojo's linear types, you must explicitly say, okay, I'm done with this resource now. The compiler becomes your safety net, making it pretty much impossible to mess up. This quote from the documentation just nails it. This isn't about making your life harder. It's about giving you, the programmer, ultimate power and responsibility. You are in full control, and the compiler is right there with you, making sure you use that power safely. Now, when you have that kind of fine-grained control over resources, what's the natural result? Speed. Pure, unadulterated speed. And these new updates bring some absolutely massive performance boosts, especially to the standard library. Okay, this is a huge deal. The standard dictionary, something we all use constantly, has been completely rebuilt with something called a Swiss table design. It's powered by SIMD, which basically means your CPU can search for a whole bunch of things at the exact same time, in parallel. For anything data heavy, the speed up is just massive. Here's another improvement that's going to make your code so much cleaner and safer: typed errors. So instead of just catching a generic error, you can now raise and catch really specific ones. This makes your error handling logic incredibly robust and easy to read. And the absolute best part, it's what's called a zero-cost abstraction. That means you get all the clarity and safety of modern error handling without paying any performance penalty. Under the hood, it compiles down to be as fast as old-school C++ error codes. It's truly the best of both worlds. And the performance train keeps on rolling. File operations are now faster because they talk directly to the operating system, cutting out the middleman. Plus, there's a new comp time keyword that lets you force parts of your code to run at compile time, which is absolutely crucial for optimizing for specific hardware like a GPU. So, with all this incredible power under the hood, what does it actually feel like to write Mojo code now? Let's pull it all together and look at the developer experience and the biggest takeaways from all of this. Just a couple of nice, small syntax changes that make life easier and your code safer. There's a new never type for functions that, well, never return. This helps the compiler reason about your code. And string handling is now much safer around UTF-8 characters, which helps prevent some really tricky bugs. And a quick heads up, if you're already writing Mojo, a couple of things are changing to make the language more consistent. The old @register passable decorator is now a trait, and you can't implicitly convert integers to SIMD types anymore. They're good changes that make the code clearer and safer in the long run. So if you remember just 3 things from all this, let it be these. Mojo now gives you 1. More productivity with reflection writing code for you. 2. More control thanks to linear types giving you ironclad resource safety. And 3. A whole lot more performance with things like the supercharged dictionary and zero cost errors. Which really brings us to the big question, doesn't it? With this powerful combination of high-level productivity and true low-level control, Mojo is making an incredibly compelling case for itself. The question is no longer if it's going to be a major player in systems programming, but when. And after these updates, for a lot of us, that time might be right now. Thanks for tuning in.